All right, let's start, guys. So, what we discussed last time. So this right here is area of a rectangle, and I'm summing up an infinite amount of them. Remember, this right here is your height, and the delta x is your width. So that's how you find the area of one rectangle, and then we're doing a infinite amount of rectangles. So that's what this means. That's what this means right here. It's equivalent. The dx is your width, the f of x is your height, the a and b is where you start. So if you want a little visual, it means this. I have a curve, let's call that f of x. I have a, I have b, and what it means is you start at a and you stop at b. So I'm finding the area under this curve from a to b. That's all it means. Does that make sense to you guys? Anything crazy right now, guys?
Infinite what?
Infinite rectangles, infinite amount of rectangles. And that's how you get that perfect area there. All right, scenario one. I'm going to draw quadrant one, everything in quadrant one for now. Well, for this one, scenario one. And I'm going to draw a curve. I'm going to call that f of x. And I'm going to use different colors. I'm going to say this is A. I'm going to say this is B. I'm going to say this is C. So this is probably a good place if you want to use different colors here. I'm going to say the area from A to B is 10. And I'm going to say area from A to B of f of x dx is 10. And then I'm going to use green. The area from B to C, I'm going to say that's 8. So integral from B to C of f of x dx is 8. Nothing crazy, right, guys? So if I write an integral like this, and I say from A all the way to C of f of x, you're going to tell me what? Not 10 and not 8. You're going to tell me 18 because you just added them up, 10 plus 8. And that is a property, one of the properties of integration, and you'll get to it in a little bit. How do we feel with that? Pretty easy? Okay. So let's go to scenario 2.
Wait.
Okay. I just added them, Miss Schmidt. The area under the curve from A to B was 10. The area under the curve from B to C was 8. So 10 plus 8 was 18. Don't worry, we're going to go into details about the properties. All right, here we go. So now I'm going to draw, let's see. I'm going to do this. Some area, some below. Okay. And I'm going to say this is A. I'm going to say B. I'm going to say D. I'm going to say D. A, B, C, D. I'm going to say the area between A and B. I'm going to say this is, what's a nice number? 10 again. I'm going to say this is 10. I'm going to say the area between B and C. I'm going to say this is 5. And I'm going to say the area between C and D. And notice the color coding that I'm doing. I'm going to say this one's 8. All right, so I'm going to draw little integrals. So up here, I'm going to say area from A to B. This is signed area. And I'm going to call this function f of x. So here it is, f of x. So A to B of f of x dx is 10. Are we still okay, guys? All right, the one in blue. Area from B to C of f of x. I'm not going to write 5. Because it's below the x-axis, take a guess. I'm not going to write 5. What do you think I'm going to write?
-5.
Perfect. -5. See, you guys are smart. And I didn't even have to tell you guys about that. Integral from C to D of f of x dx. It's above the x-axis. This is just going to be 8. And finally, and I'm going to leave that there, I'm going to draw an integral, and I'm going to say from A all the way to D. What do you think that is? Yeah, how'd you do that? Good. You add the signed areas. 10 minus 5 is 5. 5 plus 8 is 13. And that's it. How do we feel, guys? I'll wait here. You guys already wrote that down? Oh, you don't understand it? Oh, okay. All right, here we go. Now I'm going to write all the areas below the x-axis. So I'm going to exaggerate the x and y-axis, like so. And I'm going to draw this curve. And there's my f of x. Here's A. Here's B. Here's C. I just feel like doing those three there. So this area here, I'm going to say that's 10. I'm keeping the numbers pretty. The area from B to C, oh, let me use blue on this one. I'm going to say that's 8. Yeah, that's enough there. So let me do the red one. Area under the curve from A to B of f of x dx. Since f of x is below the x-axis, I'm going to say negative 10. Bless you. Integral from B to C of f of x dx. Since f of x is below the x-axis, I'm going to say negative 8. So if I write integral from A all the way to C of f of x dx, negative 18. We feel okay, guys? All right, yay. All right, this was already in your last notes. So lower limit, upper limit, integrand symbol, variable integration, integral. And then here I'm just calling the dt, the du, the dx dummy variables. It doesn't matter what letter you use. The area of the curve is still the same thing, no matter what. Cool or not cool? All right, so here are some properties. We're going to talk about them. We're going to talk all about them. Ready to chat about them? All right. So look, property number 1. If I switch the limits, so let's think about it. A to B. Hey, relax, don't worry, we'll be done pretty quick. So if you switch the limits, A to B of f of x dx equals negative integral B to A of f of x dx. Why is there a negative there? Because you're counting backwards. So look, this A to B means, okay, this right here. So you take this number minus this number, B minus A. So that was a 10 and this was a 3. This width here would be like 7. Does that make sense? But if you count backwards, that's like saying 3 minus, what did I say, 10? 3 minus 10. Does that make sense to you guys? Yeah, pretty much. This means find the area from A to B of f of x. This means pretend the negative is not there. Find the area from B to A. So now we're going backwards. So it's like quote unquote different directions. Does that? What's up? You want me to give an example, like a real one? Okay. So let's do. I'm gonna put number 1 here. Let's do a very simple one that we all know how to find the area about. So look, I'm gonna be really, really simple, guys. 1, 3. So this is just, does everyone agree that between 1 and 3, I just have this area here, and that is just a rectangle? I know it looks like a square the way I drew it, but so if I were to do this, area under the curve from 1 to 3 of f of x dx, I can say that's the same thing as this. 50 times the difference between 3 and 1, 3 minus 1. And you get 100. Cool or not cool? But now look at this. If I do this, put a negative in the front and go 3 to 1. Okay. Let me put it without the negative so you can see why f of x dx. It is still 50. But now look, I have to go 1 minus 3 because I'm going backwards. I'm reversing the order. So I'm saying this is always b minus a for a flat line. So now I'm doing upper minus lower. 1 minus 3 because I'm going in the opposite direction.
Uh-huh.
This is negative 2. You see that? So I get negative 100. But that's not what I want. I wanted to get a positive 100 because I want them to be equivalent, right? So what I'm trying to say is, let me write it in green. Integral from 1 to 3 of f of x dx is equivalent to a negative on the outside, 3 to 1 of f of x dx. And those will give you both 100, the positive 100s. Does that make sense? So anytime you switch the polarities, every time you switch the signs, the upper and lower, you switch the polarity. Cool? Is everyone okay with rule number 1? All right. Rule number 2. This one's simple. Rule number 2 says, and everyone's going to understand this one real quick without any a to a of f of x dx. Rule number 2 says this is a 0 because have you moved? Here's a, here's b, here's the curve. Have you moved? Lower limit a, upper limit a. Have you moved? No, no movement. No movement. Hence no area. Hence no area. Are we okay, guys? All right, rule number 3. I already forgot what rule number 3 says. What does it say? Constant. Okay. If you have something like this, area under the curve, I'm looking at this one in red, so maybe I should, no, that's fine. 1 to 3 of f of x dx. And I'm going to put a 2 in the front. No, I'm going to put a 3. 3 f of x dx. Doesn't that 3 means that whatever f of x was, I'm going 3 times higher? Yeah, so I can take that out if I want. 3 integral from 1 to 3 f of x dx. And look, this right here that I'm circling, that area was already 100. And then I just multiply by 3. 300. And that's all it means. And it would be true if I left it as 3f of x, then that new f of x would be 150. And then 150 times 2, I get 300 again. Does that make sense to everyone, guys? Are we okay? All right. So that covers this one. And then the sum and difference rule, guys. Look, that is just this. We just did that right now. You guys were really good at that. A, B, C. You just told me a little while ago that the area from A to C of f of x dx is the same thing as the area from A to B of f of x dx plus B to C of f of x dx. Does that make sense to you guys? Yeah. If I were to give you all the area from A to C and I subtract the area from A to B, of course you're going to get BC. Does that make sense? Okay, don't worry. We're going to do we're going to do a hella amount of examples. All right. Oh, sorry. Okay. And then the additivity one, that's just the same thing that we were just talking about. A, B, B, C, f of x, f of x. Yeah, that's the same thing we were talking about. Oh, actually, number 4 was talking about 2 different functions. Yeah, you can add 2 different functions. You can separate them, plus or minus. It's a simple property. We're going to talk about it right now. Yes. Can I go to the bottom? Yeah. Number 3. Yeah, the one that I was talking about a little while ago was number 5 by accident. Okay. Okay, you guys ready for the real stuff? All right, don't worry. It's going to go by really quick. All right, so they tell me that the area under the curve from negative 3 to 0 is square root of 2. I don't know how that looks like, guys. If you want a little visual, do you guys want a little visual? All right, here's a little visual. I'm going to put not to scale. NTS stands for not to scale. I'm going to say here's negative 3, here's 0. I have some function. The area under this curve is square root of 2. We still okay? I start at negative 3 and I end at 0. This means area under the curve of the G of T graph is square root of 2. Between negative 3 and 0. Cool or not cool? All right. What happens if I count backwards? Negative square root of 2. I'm changing the axis. Instead of calling it a t, I call it u. Is it still going to be square root of 2? Yes, square root of 2. Doesn't matter what you call the axis, guys. It's a dummy variable. Can I go to the next one? This time they put a negative inside the g of x. That's like a constant. If you want, you can put the negative on the outside like this and go negative 3 to 0 of g of x. So I'm going to get, perfect, negative square root of 2. Again, this square root of 2 is like a constant here. So I'm going to rewrite it. 1 over square root of 2 integral negative 3 to 0 of g of r dr. This right here that I'm circling is just what? Square root of 2. So I get 1 over square root of 2 times square root of 2. What is that going to be? 1. Done. Any questions on this, guys? All right. We're doing pretty good so far. Okay. I think you guys pretty much already got it. I think you guys are beasts now. All right. I know you guys are visual, so I'm going to do not to scale because obviously there's something going on between 1 and 2 that is negative. I'm just doing this for the visual aspect, guys. 1, 2, 5. And I'm going to say f of x. Don't worry, we're almost done. Are we okay so far? All right. Using the rules, from 2 to 2 of g of x, have you moved? No, so this area is going to be 0. Yay or nay? Yay. All right, this one right here. I start at 5 and I work my way towards 1. I'm counting backwards. So I'm looking at this one right here in particular. See, it says 1 of 5 is 8. So that means 5 to 1 has to be negative 8. Are we still okay, guys? Why would it be what? Oh, because that one says f. Okay. From 1 to 2, 3f of x. So I'm looking at this one right here. But there's a 3 in the front. So I can rewrite this as 3 integral 1 to 2 of f of x dx. So what is 3 times negative 4? Negative 12. All right, now we're getting to the good part where it says 2 to 5. Oh man, Chavez, how do we do that? We don't have a limit for that. All right, look, here it is. Here's my little symbol. There's obviously something going on between 1 and 2 that's negative 4, so I'm putting not to scale because I don't want you guys to freak out here. 1, 2, and 5. All right, how do I get the area under the curve from 2 and 5? Do you guys agree that if I take everything here in red, do you guys see that in red? And I delete the area here in blue, that will give me the area from 2 to 5? All right, so let me write what I just said in symbols. If I take the area from 2 to 5 of f of x dx, and I subtract the area between 1 and 2 of f of x dx, this will give me the area between 2 and 5. So there it is. There's my equation. And I have all of them. So my area under the curve from 2 to 5 for f of x is what? Oh, that's what I'm looking for. Duh. The area under the curve from 1 to 2 of f of x dx is, so here we go. I'm going to rewrite it, guys. Area under the curve from 2 to 5, f of x dx. Let me rewrite it first. Maybe this will make more sense. Area under the curve from 2 to 5. Oh, what's going on? What happened?
Is the first one supposed to be 5? That's what we're looking for.
Oh, I'm supposed to say 1 to 5. Man, plus 5 points.
I told her.
Okay. All right, let's start again, guys, because I feel like I messed you guys up. So let me start again here from the very beginning. All right. I want the red. Can you guys see the red? And I want to subtract the blue.
Yeah.
When I subtract the blue, that will give me the area from 2 to 5, which is what I want. Does that make sense? I have the area from 1 to 5. That was given to me. What's the area from 1 to 5 of f of x? Was it 10?
6.
Yeah, for f. Let me see. 6. So I'm going to write 6. I mean, you know what? I'm even going to color code it. 6 minus, well, the minus should be black, right? Minus, and then the blue part from 1 to 2. Oh, I just spit on the. I know, right? Oh, wait. This is my shirt. And then the area from 1 to 2 is -4. Does that make sense to you guys? So my final area is going to be 10. Yes. Does that make sense to you guys? Okay. All right. Here we go. Yes. On the AP exam, I don't remember. Yeah, okay. I do remember. For full credit, you're just going to have to show your steps. So you don't have to necessarily write the rule, but this would be evidence of your steps. So you would have to write that little piece out. All right, letter E, guys. I already have 1 to 5 for f of x. I already have 1 to 5 for g of x. I can just rewrite this. 1 to 5 of f of x dx minus 1 to 5 g of x dx. What is it from 1 to 5 of f of x? 6. So 6 minus, and then 1 to 5 of g of x? 8. So 6 minus 8 is? -2. Done. Yeah. Well, it depends. On the free response, this is too simple. They're not going to ask you something like this. They're going to ask you something more complicated, but you always have to show your steps for full credit. I think that would be, I think if they give you this and you just say 6 minus 8, if it were free response, then yeah, that would be full credit. But I don't think they're going to give you something that simple, you know? All right, letter F. Again, same thing. 4 integral 1 to 5 of f of x dx minus integral 1 of 5 of g of x dx. So 4 times 6 minus 8. 6 times 4 is 24. And when I subtract 8, you get what? And that's it. Do we feel okay, guys? All right. We're becoming beasts. I think this is the last example or two more after this. All right. So this one I stole from the textbook. And some of these are not possible. So it says find each of the following integrals if possible. So sometimes it's not possible. Unless it would have told us something about even and odd. All right. Letter A. So notice they have f of x, and h of x. Cool? So letter A, they switch the limits 4 to 1 of f of x. So I'm looking at this one right there. So this is going to be what? 2. Notice letter B, I'm at the right-hand side. They go from -1 to 4 of f of x. Well, check it out. This one starts at -1, stops at 1, and then this other one where f of x, it starts again at 1 and goes to 4. So add them. So what is 5 plus a -2? 3. Does that make sense to everyone? Yes, I'll write it out. Integral -1 to 1 of f of x dx plus, where this one stops, this one better start, and it does, 1 to 4 of f of x dx equals integral from -1 to 4 of f of x dx. Like that, miss? Okay. Are you happy? Yeah. Good. We want everyone to be happy. All right, YouTube, I hope you guys are happy too. Thumbs up, please. Okay. All right, here we go. Next one. Let's see if we have enough information. -101 of f of x, yes. And -101 of h of x, yes. We have enough information. There's a 3 in the front. That's fine. So let's write this one out. 2 integral -1 to 1, bless you, f of x dx, plus 3 integral -1 to 1 of h of x dx. 2 times -101 of f of x is what? -2, wasn't it? Oh, 5. My bad. 5. Yeah. Plus 3 times -101 of h of x is 7. So that is 10 plus 7, 14, 21. So do you guys get 31? No, don't look at the video. Ask. Am I going? I'll slow. Okay. Okay, I'm going to slow down.
No, because I'm ready to do this.
Okay. Sure they mean it. Okay. Area of the curve, I'm going to slow down. Area of the curve from 0 to 1 of f of x. Let's see if I have enough information. I do not. If they would have told me that f of x was odd or even, then I would have had enough information, but they don't. So I don't have enough information, so this one is not enough info.
Wait, what?
They don't tell me, there's nothing I can do to get from 0 to 1.
Oh.
You know what I mean?
Mm-hmm.
Yes.
What does odd mean?
Even means it's symmetric by the y-axis, and odd means it's symmetric at the origin. Like cosine x is even, sine x is odd.
Give that like a side note.
Yes. Side note. Even is f of x equals f of negative x, and I'm going to say like y equals x squared or y equals cosine x. And I'm going to say on this side odd is where f of x, f of negative x equals negative f of x. Like y equals x cubed or y equals sine x. So that side note. Well, that helps. If they would have told us that f of x is even, then I could just take 5 and divide it by 2. Odd. Y equals x is odd. Okay. Next one. Where are we at now? Letter E? Letter E, negative 2 to 2. Not enough information. We don't know what happens outside the bounds. We okay so far, guys? All right, let's see. What else? Letter F, negative 1 to 4. We do have enough for F, but what about for H? Nope, not enough. Yep, that's it. Negative 1 to 0. Man, letter D was so close. If they would have said negative 1 to 0 or negative 1 to 1, nope. When I subtract that, negative 1 to 0. If they would have said negative 1, it doesn't matter. Let's just stop. All right, how do we feel so far? All right, last one. Here's the last one, and that's it. The regions A, B, and C in the figure below are bounded by the graph of the function f and the x-axis. The area of region A is 18, so I'm going to put 18 down here. The area of region B is 14, so I put 14 down there. And the area of region C is 8, so I put 8 right here. What is the value of negative 5 to 8? Okay, if you're below the x-axis, it is negative, and if you're above, it's positive. So I'm going to say negative 5 starts right here, and 8 stops right there. So you're just going to add them all up. Negative 18 plus a negative 14 plus 8. Does that make sense to you guys? All right, let's see. Negative 18, negative 28, 29, 30, 1 to 2. So negative 32 plus 8, negative 24. Did I add correctly? Yes. All right, and then that's it. How do we feel? All right, so you have one little activity and one delta math. And the paper activity will probably finish it like in 5 minutes, maybe even less. Let me get the others. Oh, hold on, guys. Let me stop this video here.